Let us now look at multiplication of matrices. We refresh on that. Multiplication of a matrix by another matrix is done row by column. What do I mean by that? That is, your row 1, elements in row 1 will multiply the elements in column 1 in the other matrix. Or, and of course, elements in row 2 will multiply the elements in column 2, and so on and so forth. So that is how you carry out the multiplication of a matrix by another matrix. We shall now take more examples. Example 1. The first example will be to look at this. If a matrix S is equal to 1, 2, 0, and 3, and another matrix Y is equal to 2, 1, 4, 3, and you are required to find the matrix SY. Your solution, simply put, SY will be equal to, write the matrix S, 0, 3, and then also take the matrix Y, 2, 1, 4, 3. In this order, we will now take the first row and then multiply by the first column. So we have 1 times 2 plus 2 times 4. That will give you the elements in the first row and the first column. Then you take the same first row and multiply by the second column. So we have 1 times 1 plus 2 times 3. Then we move on to the second row and the first column. 0 times 2 plus 3 times 4. Then take the second row and then the second column. 0 times 1 plus 3 times 3. This is the order in which you carry out your multiplication. You will now simplify this to get the final result. 1 times 2 is 2, and 2 times 4 is 8. 8 plus 2 is 10, so you have the first element there. 1 times 1 is 1, 2 times 2 is 6, plus 1 is 7. Then here is 0, and that is 12. And here is 0, and that is 9. Then you put in the bracket, this is the multiplication of a matrix S by a matrix Y. And that is the result. We have example 2. Given that this matrix is multiplying this matrix, and the result is equal to this matrix, you have to find the value of K. Your solution, you have to multiply the left hand side, and that becomes 1 times minus 1 plus 2 times 2, and then again 1 times 1 plus 2 times 5. You go to the second row, K times minus 1 plus 1 times 2. You go to the next one, K times 1 plus 1 times 5. Now, this will give you minus 1 plus 4, and here is 1 plus 10. This is minus K plus 2, and that will be K plus 5. This simplifies to 3, 11, minus k plus 2 and then k plus 5. This result is equal to the 3, 11, 5, 2. Now that we have gotten this, we are required in this question to find the value of k. Therefore, minus k plus 2 is equal to 5, or your k plus 5 is equal to 2. In this wise, your k in this place will be equal to minus 3. Even if you use this, your k will be equal to minus 3. So the result is k equal to minus 3. Let's take a look at example 3. Let I here stands for identity matrix, be equal to 1, 0, 0, 1. Remember, I told us that the main diagonal will carry a unit. P is equal to this, Q is also equal to this matrix, and they are 2 by 2 matrices, such that the product of P and Q will be equal to the identity matrix. Find U, V. Now, your solution, all we need is to write your PQ to be equal to your 2, 3, 4, 5. Multiply this by Q, which is U, and then 4 plus U, and then we have minus 2B and B. Let's get out the product of this one. 2, already we know what to do. 2 times U is 2U, and the 3 times minus 2 is minus 6B. That is first row, first column. We go to the next one. 2 times 4 plus U, and then plus 3 times V. Now, we come to the second row. 4 times U, and then minus 10V. Then again you have 4 times 4 plus U, and then we have plus 5V. Now, simplifying this matrix, you will have 2U minus 6V. You have here 8 plus 2U plus 3V. This will give you 4U minus 10V. That will give you 16 plus 4U plus 5V. And that this matrix is equal to the unit matrix, which is 1, 0, 0, 1. So we're now going to solve to get the values of U and V, which will result in a simultaneous equation. So let's take 2U minus 6V is equal to 1 as one of the equations. You can also take 4U minus 10V is equal to 0 as the second equation. From equation 1, you actually have that your 2U is equal to 6V plus 1. Therefore, your U is equal to 6V plus 1 all over 2. You can now substitute for U in equation 2, where you have 4U. So 4, our U now is 6V plus 1 all over 2, and then minus 10V, everything is equal to 0. The 2 here, we cancel 4 to give you 2, so you have 2 into 6V plus 1 is equal to 10V. When you take minus 10V to the right hand side, it becomes positive. Divide all through by 2, you have 6V plus 1 is equal to 5V. For like terms, your 6v minus 5v is equal to minus 1. So your v is equal to minus 1. You can now again substitute for v in equation 3. Equation 3, where we made u the subject of the equation. So we have u to be equal to 6 times minus 1 plus 1 all over 2. 6 times minus 1 is minus 6 plus 1 all over 2. This will give you minus 5 over 2. Our result, uv, will now be equal to minus 5 over 2 command, and then minus 1. And this is the solution required of you in that problem. Example 4. If this matrix is multiplied by this matrix, the result is equal to A times this matrix. We have to find the value of A. Our solution, you multiply out the left hand side, which is 1, 2, 3, 4, multiplying 4, 5. This will give you 1 times 4 is 4, and 2 times 5 is 10. The next one is 3 times 4 is 12, and then 4 times 5 is 20. It's a color matrix, and this will give you 14, and this will give you 32. Now, we want to write your 14, 32 equal to A into 35 and 80. The only way we can do this is like factorizing this. This becomes 2 over 5 multiplying 14, and this is 32. This 35 over 80 can be written in this form. It therefore means that the A, this value now is equal to this value, so your A is equal to 2 over 5. Example number 5. If f of s is equal to 3s minus 2, and p is equal to the matrix 2, 1, minus 1, 0, and I is a 2 by 2 identity matrix, evaluate f of p. Solution. Now, you have been told that your f of s is equal to 3s minus 2. Then your f of p will now mean f of into the value of p is the matrix 2, 1, minus 1 and 0. Now what does this translate to? Remember that where you have s, and that is where the matrix p is occupying, so that becomes 3 multiplying the matrix p and then minus 2. And because you are told that there's an identity matrix, you multiply this by the identity matrix. This will enable us to carry out the following by writing this as 6. 3 times 2 is 6, and this is 3, and then 3 times this is minus 3, and this is 0, and here we have minus 2. You can add the identity matrix, which is the 2 by 2 identity matrix. So with this, you can also now see that we have 6, 3, minus 3, 0, and then you have minus 2, 0, and then this is 0, and then 2. Okay, so you can carry out your subtraction component by component and that will give you 6 minus 2 is 4, 3 minus 0 is 3, minus 3 minus 0 is minus 3, and 0 minus 2 is minus 2. And this gives you the result that you are looking for. Exercise. Question number 1. If A is equal to this matrix and I is a 2 by 2 unit matrix, evaluate A squared minus 2A plus 4I. Options A, B, C, D are provided. Question number 2. If P is equal to this matrix and Q is equal to this matrix, find PQ plus 3Q. Options A, B, C are provided for your answer. Question number 3. P is this matrix and Q is this matrix here. If PQ is equal to this identity matrix, AB equals A, B, C, D. Number 4, if this matrix multiply this matrix and the result is equal to this matrix, what is the value of R? A, B, C, and D. Number 5, find the values of X and Y respectively if this matrix plus this matrix is equal to this matrix. The options are A, B, C, and D. Here are the answers to the exercise. Question number 1, option C is correct. Question number 2, the option A is the correct one. Number 3, D. Number 4, D. Number 5, D.